we've seen domain, right? Now, since we're looking at fractions, we know that the denominators cannot be 0.
I'm sorry, did you?
So yeah, denominator. Whenever you see denominators, it's going to say, or these rational functions. Just remember the denominator can be 0. So this goes back to what we saw, what was that, last night, 4.8, 4.7? At the denominator here. Remember, with these, and we've seen these before, I don't really care about the numerator. Even if I can get rid of stuff with phantom ones. Just remember, if you saw something like this, so let's do that x minus 9. Let's see, add another one even, like a x plus 5 right here. So maybe you started with the trinomial that produced this as a factored two binomials right there. Then you'd have to know, and of course this would come with some work, that x could not equal 9 or negative 5. Because if it did, it would make the denominator, if you replace this x with 9, you'd have 0 times 14, but you'd get 0. And you can't get that. You can't get zeros in denominators. So that, again, that's a pretty direct relation to what we saw last night in whatever it was, 4.8. And then also if you replaced x with negative 5, you'd get a 0 here. You'd have negative 14 times 0, which is still 0. You can't have that. So we know, and we can declare this as part of the domain. Just don't make x 9 or negative 5. We can do that with an interval notation. We can do it with kind of a direct inequality statement like this. Depends on how they want it on the assignment, but they're going to want it, okay? So you can't have denominators that are zeros. And then let's just tack this on again. So let's say there was even an x out there. Then x couldn't be 9, negative 5, or even 0 on this, which could happen, okay? So don't make those, don't let your denominators be zeros. But again, if you are struggling to solve those equations from 4.8 or whatever it was, then you may have to go back and study that stuff a little bit more, okay? All right, find the domain of f, that's f of x, and write your answer in interval notation. So this one, we're not looking to get rid of the phantom ones. It's just asking for the domain. Well, it's a fraction, so the whole numerator up here, I don't really care about it. I don't care what's there. I don't care if it can be factored. I don't care if it can be taken away as a phantom 1. I don't care about that. All I care about is the denominator, which shows is x squared minus 9x plus 14, okay? So I need to see what this is factored, right, so that I can figure out what not to make 0. Okay, so my leading coefficient is 1, so I'm going to take 14 and split it up. It looks like, so I'm going to skip some of the extra pairs here, but it looks like it should be negative 7 times negative 2. Negative 7 times negative 2 is 14, but negative 7 plus 2 is negative 9. Of course, there's other factor pairs, right? You got 1 and 14, you got 7 and 2, you got negative 1 and negative 14. None of those matter. It's this one. This is the one that we want so that we can make this then factored, right? So I'm just taking a shortcut. I'm not going to factor by grouping here. I got x minus 7 and x minus 2. Now this is, if you wanted to, you could say then that the new fraction, again, I don't really care about the denominator. I'm sorry, I don't care about the numerator, but the denominator now is x minus 7 and also x minus 2, okay? Again, I don't care about the numerator. Why do I only care about the denominator? Because it's asking for the domain, so I need to know what x cannot be. Well, if I were to do that, then I would have to make sure that this, even as a full equation, cannot equal 0. Okay, so but it goes back to what we did in 4.8. So it would say, look at this x minus 7 business, okay? If it were to equal to 0, it would make my full denominator equal to 0. I can't have that. I don't want it. So I've got to make sure that this does not equal 0. So I'm going to solve it just like I would an equation, though, by adding 7 to both sides. And then I see that x, because that zeroes out, could not equal positive 7. So that's part of my, that's one of the main values I need to remember in my domain, which we'll get to interval notation. But then in addition to that, the other binomial, x minus 2, I need to make sure it cannot equal 0 as well. So again, solving this like an equation, I would add 2 to both sides. That zeroes out. X then, it cannot equal 2. Now there's going to be problems where it says, hey, just tell me what numbers it can't be, and that would be great. But this one, it says it wants interval notation, okay? So I'm going to take this, And then I like to see interval notation with a number line right here. So that'd be 0, 2, and 7. Again, I just like to see where 0 would be. So what happens here? Well, I know that x can't be 7, so I got an open circle at 7. I know x cannot be 2, so I got an open circle at 2. There's no other restrictions on the domain. You could have any other fraction, any other number, any other integer, anything else works. So, no, you're good. So that means everything to the left of 2 would work. It means everything between 2 and 7 would work. And it means everything to the right of 7 also would work. So we need to show this interval notation, but to exclude 2 and 7, right? So I'm going to start, I always start myself to the left. So I know that that line in orange goes all the way to negative infinity, rather.
Oh.
Then yeah, there you go. So it stops at 2, which is not included. So I've got a parentheses there. And then I'm going to start back up. So I'm going to unite this at 2, but again, it can't be included. And then that is going to go all the way to 7, which also cannot be included. And then I'm going to unite that with this other orange line going to infinity, but that would start at 7, not included still, but then it goes to infinity, which also is not included.
So the first time we're seeing it?
So we have seen examples with just the one u, but now we're looking at a 3-part union on this, okay, with the interval here at the bottom.
Can you